Hey guys, and today in this math video, we are going to learn how to look at z-score and different calculator functions relating to statistics. So let's get started. So first, we have our normal PDF function. And in our previous video, we looked at the z-scores, normal distribution, and also how to look at all the significant points for a set of data. But today, we are going to be looking at how to use that data to find something related to probability, percentages, and just basically kind of putting your data into manageable categories and finding them based on a wide variety of ranges. Okay, so our first distribution function is going to be normal PDF, which if you actually go to your calculator and click second vars, which is then the distribution button, number one you will see as normal PDF. And what this basically means is that we are inputting in here our x value, and then our output will be the probability of that x value occurring. And remember, our x value is just a random data point from our data set. And then the probability of that occurring, that's going to be, of course, a percentage. So if you guys want, we can just go ahead and write that it's going to be as a percentage. Okay? And then for our normal CDF function, we're going to have our input be a whole range of values, while our output is going to be that probability of that range occurring. And again, it's going to be as a percentage. Now, if we go ahead and look at our normal PDF button, if you actually click that, you will see that there's an X value to enter, your mu, which is the mean, and we discussed that in the previous video. So if you have anything questions on that, or you are confused, then go ahead and just look at that. And then there's our sigma, which is the standard deviation for a population. And then after you enter those pieces of information in, all you have to do is click paste, and it will show you that probability. If you go ahead, go to second mode, which is going to be our quit button, and then go back to second vars, back into that tab with all the options. Number two will be normal CDF. And like we described, our input is going to be our range. But what it does for our range is going to be a lower and upper bound. So I like to write LB for lower bound, and then range, that's going to be our upper bound. So you could say UB. So lower bound is really your minimum value. So let's go ahead and look at this bell curve over here. And that if we want to find a specific data set, which is, let's say, from this point to this point, this right here is going to be our lower bound. And then over here, this is going to be our upper bound. So that's really what we enter in our calculator. And of course, it gives us a percentage as our output. So the probability of that whole range occurring. So that's really the difference between normal PDF and normal CDF. And then if you go back to that distribution tab, you will see as number 3 as inverse norm. And you might be asking, what really does that mean? Well, let's take a look. If we say inverse norm, we're going to have our input be a probability of a whole of an x value really occurring. And then our output will be the x value. So really, what we notice here is the word inverse. And we can guess that it is the inverse of something. Inverse of normal distribution, which is actually this first function. So really, it's the inverse of normal PDF. And what we see here are the kind of inputs and outputs are just switched. Inverse norm, we have our input as a probability of an x value or observation in our data set occurring, while our output is the actual x value. In the normal PDF, our input is the x value, well, the calculator gives us that probability. So that's really easy for us to say identify, because basically their functions are just listed in their name. So let's go ahead and take a look at some of the examples or example problems that we may encounter. All right, so if you have normal PDF, which we're really not going to be using as much, but it is still good to know about it. So for normal PDF, say that you have like an SAT score of, so let's go ahead and write here number 1, which is our normal PDF. If you have an SAT score of 515, well, let's not say 515. Let's say an SAT score of 635. And then 635, that's going to be our X value, okay? So if you guys want to go ahead and do this along in your calculators, go ahead and press second bars, go to number 1, normal PDF, and type in as your X value 635. And then our mean, I will be saying this in the video, our mean is going to be 515. So 515. And then our sigma or standard deviation will be 116. And then we're just going to go ahead and paste and enter paste. So just click enter and then enter again, because it shows you all the numbers you entered within the brackets. And you will, in fact, get a percentage, or first you'll get a decimal point of 0.002, but then of course that's going to translate into 2.0%, which is really hard to get given these situations. So that would be an example for a normal PDF. As we see here, we're given an X value and our output is a probability. All right, so let's go ahead and look at number 2, normal CDF. And an example problem of that would be that, let's take a look at this problem. The average sugar in 23 kinds of cereals is 7.6 grams of sugar per serving, with a standard deviation of 4.5 grams. And if you have the same worksheet as me, it's basically your day 8 homework of Z-scores. So you could just go ahead and follow along. Over here, our Frosted Flakes is 11 grams of sugar per serving. Our Apple Jacks is 14 grams of sugar, and Honey Oats is 3 grams of sugar per serving. And then A asks what percentage of the cereals fall between Honey Oats and Apple Jacks. And this is a perfect example of when to use normal CDF, because you are given with a range and they want us to find the probability, as they are asking for a percent. So go ahead and take a look at the problem and pause the video if you want to try to go ahead and figure it out. But let's get started. So it says 7.6 grams of sugar is our standard deviation. 7.6 grams of sugar is the average, so mean, and then 4.5 is our sigma. And then it says between Honey Oats and Apple Jacks. So Honey Oats is going to be 14 grams of sugar per serving, and then Honey Oats is 3 grams. Apple Jacks is 14. So that's basically your range, because it's between Honey Oats and Apple Jacks. So Honey Oats is going to be 3, while Apple Jacks is going to be 14. And that's really our range. And we like to go ahead and write it as this. And I did explain this format in one of my earlier videos, so if you have a problem on this, go ahead and view those so you can gain more clarification. So we know 3 is going to be our lower bound, is less than Z, which is our Z score, is less than 14, because that's how many grams of sugar Apple Jack has. And then basically go ahead and enter that in your calculator as your second bars. Go ahead, go to CDF. Lower bound is 3, upper bound 14. Our mean is going to be 7.6, and our sigma is 4.5. And then you get 76 or 77%. So guys, I hope you like this